We're going to move on to adding fractions with unlike denominators now as we continue through section 3.5. So if we just try to add these two, we can see that 1/2 and 1/3, here's our whole part and we split it into two. So this represents our 1/2. And here's the whole big rectangle. We split it into three parts. So that would be represented with 1/3. And when we want to try to add those, we get this. But it just looks kind of weird and it's difficult to do. But we just got done talking about LCMs. And if I can find an LCM of 2 and 3, then I could split the whole parts, the big rectangles, I could split them into equal parts. And so if I have 2 and 3, well, only 1 goes into that, and that leaves me with a 2 and a 3. So 1 times 1 times 2 times 3, the LCM is just 6. So knowing that our LCM is 6, that means if I divide these boxes into sixths, like this, now you can see that instead of 1/2, what I really have is 3/6. And instead of 1/3, if I divide them into 6 equal parts, now what I have is that is 2/6. So instead of 1/2 plus 1/3, my equation has now become 3/6 plus 2/6. And we have common denominators. We know that should be 5/6. And if I come back here and I divide this into equal sixths, what I have is 5 out of the 6. So that's what we're going to be doing when we're adding unlike denominators, is we're going to be getting common denominators and then adding the numerators. Okay? On the next page of your notes, this problem is basically what we just did. So you could fill that in with what we just did. That idea of 1/2 plus 1/3. Well, that becomes 3/6 plus 2/6 makes 5/6. Sorry, I'll fix that. There. Now it became a 6. Okay. So that's what we're going to be doing here, is we're going to be drawing the original problem, talking about the holes, and then we're going to cut those holes up into pieces. And the number of pieces that we need is going to be the LCM of the denominators. Now that LCM, we also call it an LCD because specifically it has to do with denominators. All right, let's do a few of them here together. The first one I have is 1/2 and 1/4. So if we take one whole part and we shade in, or we cut it in half, shade it in. So this right here represents the 1/2. Right? This is 1/2. And when we talk about 1/2 and 1/4, the LCM is, of course, just 4. So that means that we're going to split these into 4 parts. That's why we went boop, boop, like that. And you can see that over here in this other part. The 1/4, of course, is this hole right here. We had 1/4, 1 out of the 4. And now when we put those together, you can see we've got 1, 2, 3 of them are shaded. So 1, 2, 3 shaded out of the 4. That's how we end up getting 3/4. So we took the 1/2, we found the LCM between 2 and 4, and then we made sure they all had the same number of boxes. Okay. Here we go. How about we do 1/2 plus 1/6? Well, 1/2, that's easy. Now I have a half, and I'm just going to color in one of them. And 1/6 will look like this. There. And we just want to color in just one of those as well. So there. If I want to add those two together, I've got to find the LCM or the LCD, whichever you want to think about it, of 2 and 6. So I know 2 goes into that 1 and 3 times. And so 2 times 1 times 1 times 3 means the LCD, or the LCM, will be 6. So if I cut everything into sixths, then I'm good. So we'll do that. There we go. I'm going to color in the same amount, right? So that's the same amount that I had colored before. There's the same amount. And then ultimately, we've got, when we count the parts that are shaded, I've got 1, 2, 3, 4 parts are shaded. 1, 2, 3, 4 parts are shaded. So then I could say that 1/2 plus 1/6 actually becomes 3 out of 6 plus 1 out of 6 makes 4 out of 6. Now 4 out of 6, that's actually, that becomes 2/3. I know because a 2 fits into each one of these, right? You divide the top by 2 and the bottom by 2, and then what I get is 2/3. That's a little bit nicer answer. It's more simplified than the other one. Okay, so if I take 2/3 and 1/6, so we've got, there's thirds, and there's my sixths. So we'll take 2 of them, and we'll take 1 of these. We're going to add 2/3 plus 1/6. So I'm going to start out with that, and we'll also get our sixth going here. And we know that this much of it is shaded. I'm just kind of copying the same box over. The thing is, though, that I want to see between 3 and 6. Well, the LCD is going to be 6. Hopefully you know that. You can like shortcut this and be like, well, 3 times 1 is 3, 3 times 2 is 6. Oh, I'm done. It's 6. So that means if we convert everything into sixths, we'll be good. There. Now I have 6 pieces, and I've got 1, 2, 3, 4 of them shaded. And so when we finish this out over here, I've got 4 shaded from the yellow, I've got 1 shaded from the blue, and that's going to make a total of 5/6. If we were thinking about this in terms of a mathematical equation, though, I would say 2/3 plus 1/6 is going to become 4/6 plus 1/6 makes 5/6. Okay. All right. The last one that we have here for the coloring in portion of this, 1/2 and 2/3. So I'm going to start out by making those all the same. Now we've done this enough with 2 and 3 that you guys know the LCD is going to be 6. Why don't you go ahead and finish this one? Like pause it, make sure you understand what's going on here, and then try to do this one on your own. So pause it here and then see if you can come up with the same thing that I do. Okay, so this is all set up. And I've got to turn this into sixths, right? So I have halves, and I need 6. There we go. There we go. And then what I get, I've got 1, 2, 3, 3 yellows. So we'll do 1, 2, 3 yellows, and then I've got 4 blues. 1, 2, 3, 4 blues. So you can see that in total, I have 7 out of the 6 shaded. You could also think of it as having 1 whole shaded. So we could have 1 whole shaded and then 1 left over and then 1/6 left over. So 7/6 is the same thing as 1 and 1/6. Right? So 1/2 plus 2/3 is going to become 3/6 plus 4/6 makes 7/6. Okay. All right. Right now, maybe kind of think about what we've been doing. Describe the process for adding fractions with unlike denominators. We know that for like denominators, it's just go right across the top and keep the denominator the same. Right? But for unlike denominators, we're going to find the LCD. After we have the LCD, then we rewrite the fractions with our least common denominator, right? With the LCD, with that common denominator. And then we just add the top. The bottom stays the same. And then for step number 4, we're going to simplify, if possible. You might not always. There we go. That's how you add fractions with denominators that are not the same. Let's go ahead and do some where we're not actually just drawing the pictures, because this is a little more practical as far as actually adding fractions. Drawing them out doesn't always seem to work. So we've got to find the least common denominator. All right, so when I see 4 and 6, I've got to find the LCD of 4 and 6. So maybe you know what it is, maybe you don't. I know that 2 goes into each of those, so 2 and 3, and that's going to be it, right? Nothing else is going to go into those, so I'm there. 2 times 1 times 2 times 3 makes 12. So my LCD is 12. I can think of this now as having some amount of twelfths plus some amount of twelfths. Okay? So 1/4, in order to become twelfths, I would actually multiply this one. What do I take times 4 to get to 12? Well, I would multiply by 3. So whatever I do to the bottom, I've got to do to the top. So I would take this one times 3 as well. That would get me 3/12. So 1/4 becomes 3/12. What do we take times 6 in order to get that to be 12? Well, if I have 5/6, I'm going to multiply that by 2 in order to get it to be 12. So that will become 12 on bottom, and that will become 10 on top. So that's how I end up getting my 10/12. Now I just add straight across the top. So 3 plus 10 makes 13. And then the denominator, am I going to do 4 plus 6 and make that 10? No, of course not. I just went to all the trouble of getting common denominators. And you keep the denominator the same. 13/12. You can check it on your calculator if you want. Most calculators will do fractions. Okay. All right. 15ths and 9ths. Ooh, what's the LCD going to be for those? So I look over here. I know 3 goes into this, so that'll be 5 and 3, and that's it. That's the only thing that's going to go into them. We're stuck now. So 3 times 1 times 5, that's 15, times 3 makes 45. Okay. Now, the next thing I'll do is I'll take 4/15, and I'm going to take that times 3 in order to get that to be 45ths. So if I do that to the bottom, I got to do it to the top, and that gets me 12 45ths. Then I've got to do the same thing for the 5/9. So I'll start out with 5/9, and I would ask myself, what do I multiply by in order to get that to be 45? 9 times 5 is 45, so I'll multiply a 5 on the bottom and the top. That's going to make 25 45ths. Now that I have a common denominator, I leave the denominator the same, and I'm going to add 12 plus 25 to make 37 45ths. Now those are relatively prime. 37 is a prime number, so there's nothing that goes into it. There's no simplifying that can happen. Okay. All right, next let's look over here at these fractions. We've got 13 14ths and 15 18ths. Okay, we've got to find a common denominator for those. So 14 and 18, I know that 2 goes into them. That'll be 7 and 9. After that, I'm done. Nothing else goes into them. So I just get 2 times 1 times 7 times 9. Well, you know what? I'd rather do 9 times 7 and get 63. That's using the associative property. I decided to do those first. 9 times 7 is 63 times 1, still 63, times 2. That's going to be 126. Oh my goodness, look at that. This is a huge denominator. 126. Okay, so now I've got to figure out 13 14ths times what, top and bottom, equals 126. Well, you know, something that's kind of interesting here is 2 times 7 is 14. 14 times 9 is 126. That's where that came from. That's just a 9. I'll multiply a 9 on the bottom and the top. Okay, and that will be, let's see, 13 times 9 gets me a 97, it looks like. Oh, it's a weird one, right? 97 126. No, that's not right. Why didn't you? I'm glad you guys were yelling at the computer screen there, because I heard you. I heard you. It's not 97. I forgot to carry the 2. I think I said it, and then I didn't actually do it. So that's 27. Carry the 2. That's 117. There we go. Thanks for correcting me on that. Okay, next I've got to take 15 18ths. 15 18ths. And by the way, you could reduce that. But that's not going to get us where we want, because we want to multiply times something on top and bottom and have it equal to 126. And you know, when I look back over here, I know that 2 times 9 is 18. And that just leaves me a 7 left over. So I bet if I multiply 18 times 7, that will give me 126. So I got to do 7 on bottom and top. This comes out to be 105. I feel pretty confident about that. I don't think I made a mistake there. 105 over 126. Next, I'll add those together. 97 plus 105. Well, that's almost like 100 plus 105 is 205. But then I got to add 3 less. So 3 less than that. Right? That's how I end up getting my 2 oh, doggone it. Did I seriously write 97 up here? Unbelievable. I changed it down here and I didn't change it up there. Man alive. You guys were still yelling at me and I just wasn't listening. There. Okay, finally we can add this up correctly now, and I will get 222. Wow, sorry for that. But you know, I make mistakes too. I'm just glad that I was able to catch it, or you could tell me. Now, the next thing that we're going to look at here is we've got to work on reducing these. Right away, I see that 2 goes into each of them because they're even. So I'll divide the top and the bottom by 2. That gets me 111 over 63. Because of my trick with 3's, I know that each of these will be divisible by 3. We've talked about that in the past. 3 goes into this 37 times, and 3 goes into that 21 times. Whew, that's an ugly one. 37 21sts. That's about as hard as they come, I think. That's it. All right. I'm going to clear some of this out to make a little more room for this guy. Besides, I had so many mistakes in there, I just want to forget it. Let's just clear up a little bit of room here. All right. The last one here, I've got 2, 8, and 12. I've got to get a common denominator between 2, 8, and 12. Well, good news. The common denominator between 2 and 8 is going to be 8. And so that just means I need to find what's common with 8 and 12. And maybe you've done this one enough times to know that it's 24. Maybe you don't know. There. 4 goes into 8 and 4 goes into 12. So 4 times 1 times 2 times 3 equals 24. That means we need to change all three of these into 24ths. Right? 24ths, 24ths, and 24ths. So I'll kind of think to myself, and by myself I mean to you guys as well, what do I take times 2 to make 24? Well, I'm going to take it times 12 on top and bottom. That's how I get 12 times 1 is 12. 1/2 becomes 12 24ths. What do I take times 3 to make 24? I mean, what do I take times 8 to make 24? A 3. There we go. We'll do that top and bottom, and that means that 5/8 is going to be equivalent to 15 24ths. And this last one here, what do we take times 12 to make 24? Well, we're going to multiply it by a 2 on bottom and on top. That will make 20 24ths. We'll go through and add these up. I get 27 plus 20 makes 47 24ths. Okay. Now, you're going to want to do some more practice because adding fractions with unlike denominators is very challenging. But if you can get this down, then subtracting fractions with unlike denominators is going to be super easy. So make sure you go back and practice this plenty. Go to your assignment right now even and do some of these before going on.